So we've verified that it changes throughout the year. That's got a piece called a periodicity, right? Meaning that there is like an actual cyclical period to the readings. Like the equinoxes and the solstices and the solar motion and the lunar motion, where the sun is and the moon is in their cycles, affect the readings, which means we're detecting stuff happening in the sky, not the Earth moving, because the Earth would be rotating the same way every day. It wouldn't change throughout the year. It doesn't care if it's July or August. Okay? It doesn't care if it's December. It doesn't care if it is equinoxes. It's always spinning the same. Therefore, definitively disproving the claim that you're detecting Earth spin. There's no way around it. It also changes with altitude, but it couldn't change with altitude because the angle down to the latitude on a sphere remains the same regardless of altitude. So if you're detecting Earth spin, it would remain the same at latitude when you keep the latitude the same regardless of changing altitude, but that's not what we see. It would also stay the same throughout the year, right? Because it always spins the same regardless of what time of the year it is, but that's not what we see. Therefore, the periodicity and the change with altitude refutes the claim that is the Earth spinning. Therefore, ring laser gyros, which flat earthers used to say, oh, well, correlation doesn't equal causation, and they would talk about how it maintains rigidity in space. Some people would call it a parlor trick, all this other stuff. No. The answer is yes, we can use interferometry to show us a relationship between the light, the measurement with light, and what happens in the sky, right? Because Michelson, Gale, Pearson, it matched the prediction of the sidereal rotation, which is the sky spinning, within 98% accuracy, right? They wanted to hijack that and claim, oh, see, we measured the Earth rotating. Problem number one is Michelson-Morley, assuming the orbit with the same exact framework and technology, did not measure the orbit. Okay, so what that means is there is only one viable option. It's that there is a real rotation, but it's of the sky. That there is no orbit. There is nothing else to measure except for that rotation. And then to staple that on, we kept doing the test and replicating it and showing that the interferometry measurements changes with altitude. It has a preferred direction. It changes, and the preferred direction is, of course, the same thing as measuring the rotation in the first place, right? Preferred direction, the direction that it's rotating, right? And that is the sky that's rotating. And it changes with altitude and time of year.